Close my phone.
It is 7:10, and I think we can start today's live interaction session. So, as of now, the participants have not joined, but I hope that some of them will be joining eventually, or you can watch the recording, which will be uploaded on my YouTube channel. I will uh, stop the video and start today's live interaction session. So I welcome all the participants to this third week of the live interaction session of the NPTEL course, Advanced Reinforced Concrete Design. This course is brought to you by NPTEL, and the course instructor is Professor Surya Prakash from IIT Hyderabad. And presently, we are in the week 3 of the live interaction session. And this session is presented by me. My name is S. Lalit Sagar. I'm a doctoral candidate and PMR fellow in the Department of Civil Engineering at IIT Delhi. So this would be the agenda for today's session. So uh, in week 3 of this course, we have studied the durability aspects in reinforced concrete design. So essentially this module has 4 components. So in module 3.1, we were basically introduced to the concept of durability in reinforced concrete systems. And in module 2, we studied the various deterioration mechanisms in reinforced concrete with a focus on the chemical deterioration mechanisms. In module 3.3, we looked at the other types of deterioration mechanisms, that is physical, mechanical, and corrosion in reinforcing bars. And in module 3.4, we considered the design approaches towards the durability aspects in reinforced concrete design, and what are some of the codal provisions which are existing for ensuring durability in the reinforced concrete design. Okay, so I think we can start with the questions, the multiple choice questions for today. There are about 20 questions which we are going to be discussing in today's live interaction session. Okay, so yeah, here it goes. So the first question is, which of the following mechanisms are not associated with the physical and mechanical deterioration of reinforced concrete? Okay, so I have given 6 types of mechanisms which are observed in reinforced concrete structures. So we need to identify those mechanisms which are not associated with the physical and the mechanical types of deterioration. Okay, so so this question has multiple correct answers. So please take 1 or 2 minutes and let me know what is the correct response. So I think we can look at the correct answer for this particular question. So the correct options for this question are options C and E. Okay, so yeah, so essentially abrasion is a type of mechanical deterioration. Freezing and thawing is a physical deterioration. Sulfate attack is a chemical type of deterioration, and erosion is a kind of mechanical deterioration. And further, the corrosion of steel reinforcement, it can be classified as an electrochemical uh, mechanism of uh, deterioration, and cavitation is a mechanical form of deterioration. So we're going to be looking at each of these uh, types of deterioration in detail in the upcoming slides, right? Uh, so I think we can look at the broad classification of the different types of deterioration that is observed in reinforced concrete. So we have broadly for concrete deterioration, we have the mechanical deterioration, we have the physical deterioration, and the chemical deterioration. And then for the corrosion and reinforcing bars, we have we have corrosion through the carbonation of concrete and the ingress of chloride ions. So yeah, essentially abrasion, erosion, and freeze and thaw. These come under the mechanical and physical deterioration processes, and the rest of them are the chemical deterioration and the corrosion in reinforced concrete, right? So to sum up, uh, just to sum up and explain the correct answer once again. So option C and option E. So they do not belong to the physical and mechanical deterioration processes in reinforced concrete, because sulfate attack comes under the chemical deterioration, and corrosion of steel reinforcement comes under the chemical or the electrochemical uh, or the corrosion type of the degradation. Okay, so we'll be looking at each of these uh, forms of deterioration in detail with the corresponding figures in the future slides. Okay, so we'll move on to the next slide. Next question. So the second question is, match the following transportation mechanisms with their definitions with respect to the concept of durability in reinforced concrete. Okay, so we have four different types of transportation mechanisms and their corresponding definition. So we need to match the transportation mechanism with the corresponding definition. Okay, so we have four transportation mechanisms: permeation, diffusion, migration, and absorption. Kindly take 1 or 2 minutes and let me know what would be the correct response. So I think we can look at the correct answer now, right? So the correct answer is option C. Okay. So let us look at the definitions in detail. So as we know, so reinforced concrete is susceptible to various types of deterioration. So what causes deterioration is that in the concrete mass, there can be pores within the concrete mass, and the transportation of the ions and fluids within the mass of concrete is responsible for the deterioration of the concrete quality. Okay, so in order to preserve uh, the quality of concrete, it is important to understand the different transportation mechanisms so that the correct repair and maintenance uh, repair and maintenance procedure can be adopted. Okay, so there are different types of transportation mechanisms within concrete with respect to the ions and fluids. Okay, so the process of absorption is by the capillary action, uh, and the process of permeation is defined as the flow of the ions and fluids under the pressure gradient. Okay, further, diffusion is defined as the flow of ions and fluids under the concentration gradient. Okay, and finally, migration is defined as the movement of the ions and fluids due to the applied electric field. Okay, so once we have defined, there are different test methods uh, which are adopted in order to evaluate the quality of concrete with respect to the corresponding mechanisms. So for absorption, we have the sorptivity tests, and for the permeation, we have the oxygen permeability, and to check the diffusion, we have the bulk diffusion and the rapid chloride permeability test, or the RCPT. And finally, in order to assess the migration, we have the RCPT test, we have the accelerated chloride migration, and so on. Okay, so let us go back to the question and look at the transportation mechanisms and the corresponding definitions once again, so that they're appropriately matched in the answer, right? So the correct answer is option C, and we have permeation. So permeation is defined as the movement of the ions and fluids under the pressure gradient, right? Movement of the ions and fluids under the pressure gradient. Secondly, we have the diffusion. Diffusion is the flow of ions and fluids under the concentration gradient, right? Then we have migration. Migration is the movement of ions and fluids under the electric field. And finally, we have absorption. Absorption is defined as the capillary action. Okay. So as I already mentioned, in order to preserve the quality of concrete, it is very important to limit the transportation mechanisms. Okay. First of all, it is important to ensure that the porosity of concrete is not significant, because whenever there is porosity within concrete, it leads to the various transportation mechanisms which can lead to the degradation of the quality of concrete. Okay, so the correct answer is option C. So I will reiterate the options once again. So permeation corresponds to the flow under pressure gradient. Diffusion corresponds to the flow under concentration gradient. Okay, so the concentration is The concentration gradient refers to the concentration of the fluids or the ions which are present within the concrete mass. Then migration, we have movement under the electric field, and absorption is defined as the capillary action. So the correct answer is option C. Okay. So we'll be discussing about the tests in another question in the future. So we'll proceed to the next question. So in question 3, we have a numerical problem, right? So it is given that the diffusion coefficient, that is DREF of the Portland cement concrete for a reference time of 28 days, that is reference time is the symbol of reference time is TREF, is 8 into 10 to the power minus 12 meter square per second. Now, what would be the diffusion coefficient for 365 days if the Portland cement or the PCC is replaced by 10% fly ash and 10% blast furnace slag? Okay, kindly take 2 to 3 minutes, work out this numerical problem, and let me know what is the correct response. Okay, so the equation or the formula for the diffusion coefficient has been provided in the lecture slides, and how the diffusion coefficient varies with respect to uh, addition of certain supplementary cementitious materials such as fly ash and blast furnace slag, and how it varies with the reference time has been given in that particular equation. So I request you all to have a look at that equation and let me know what would be the correct answer. So I think we can look at the correct answer now. What is the solution to this particular problem, right? So the correct answer is option E, 3.37 into 10 to the power minus 12 meter square per second. So now let us look at how we are getting the answer. Let me connect the pen. Okay. So the equation for diffusion coefficient, right? That is dt. Excuse me. The equation for diffusion coefficient dt is given by dref into Tref divided by T whole raised to the power m. Okay. In this equation, Dref refers to the diffusion coefficient at a reference time, let's say T naught, and m is a factor which depends on the percentage of the fly ash and the blast furnace slag which is being used. Okay. So let us start. Okay, let us start. We'll solve the problem. So I think there is one participant. Would you like to me to just show you the problem? So here is the problem. We have around 20 questions for today. So presently we're in the third question. I hope that my screen is visible. Okay. So the participant has left. So okay. So we have the third question, which is respect to the we are calculating the diffusion coefficient of the Portland cement, right? Okay. Uh, so M represents a factor which depends on the percentage of fly ash and the percentage of blast furnace slag. Okay. So let us start with the calculation of this factor M, right? So M is equal to, oh, sorry, wait. M is equal to 0.2, 0.2 plus 0.4 times what is percentage of fly ash? That is 10%, right? Both the fly ash and blast furnace slag are 10%. That is 10 by 50 plus 10 by 70. So when you work out this, we get the value of M as, what's the value of M? 0.337. Okay. 0.337. Okay. Now we need to find out the diffusion coefficient corresponding to a reference corresponding to a time of 365 days. Okay. So I'll take a different ink and I'll work out the problem here only. Okay. So dt, so dt is equal to what is dref? Dref is 8 into 10 to the power minus 12, right? 8 into 10 to the power minus 12 into, so Tref is 28 days. So this value of Dref is corresponding to Tref of 28 days, right? 28 divided by 365. That is the period for which, that is the time for which we need to determine the diffusion coefficient raised to the power m, and the value of m is 0.337. 0.337. So when you work out this, we get the value of dt, or the diffusion coefficient, as 3.366, 3.366 into 10 to the power minus 12 meter square per second. Okay, this is the value of diffusion coefficient corresponding to a time of 365 days. Okay, so I need to note, I want you to make one observation. Okay, so okay, I'm going to write it over here. Let me take a different color. So we have dt corresponding to 28 days. Okay, then we have dt corresponding to 365 days. So the value of dt for 28 days is 8 into 10 to the power minus 12 meter square per second. On the other hand, for dt of 365 days is 3.366 into 10 to the power minus 12 meter square per second. Okay, so what this means is that the diffusion coefficient has reduced when compared to a concrete of 28 days to that corresponding to 365 days. So what explains this reduction is that the process of hydration, the hydration of cement, okay, the process of hydration of cement, okay, and the formation of the hydration products and the CSH gel, or in other terms, the hardening of concrete, that leads to the reduction of the diffusion coefficient, okay, which makes the concrete resistant to the various transportation mechanisms. Okay, so for those of you who are interested, I would like to suggest one more problem. So you can just try finding out what would be the diffusion coefficient corresponding to 365 days for the ordinary Portland concrete, cement concrete. Okay, find out for PCC without any replacement of fly ash or the blast furnace slag, and compare that value with respect to this value. Okay, and try to understand uh, what are the implications of replacing concrete with fly ash and the blast furnace slag. Okay, so yeah, just to sum up, the correct answer is, we found out that it is 3.36 into 10 to the power minus 12. That is, option E is the correct answer. Okay, we'll move on to the next question. Right. So in question 4, it is related to the question 3. Okay, what would be the diffusion coefficient of the given cement, the given concrete sample, if the cement is replaced with 20% fly ash and 20% blast furnace slag? Okay, Please take few minutes and let me know what is the correct response. Okay. So the equation that we used in the previous problem holds good for this question as well. So it is only that the factor m that changes depending on the percentage of fly ash and percentage of blast furnace slag which is being used. Okay. Okay, so I think we can look at the answer now. The correct answer is again option E. Now let us look at the calculation for this particular problem. Okay. So we are aware of how to use the equation. Okay. Let us start solving the problem by plugging in the values. So the value of m, okay, now it becomes how much? M is equal to zero point 0.2 plus zero point 0.4 into 20 by 50 plus 20 by 70. So how much does the value of m become? So the value of m is 0.474. 0.474. Okay. Now let us plug it in the equation. Mind you, the time for which we are calculating the diffusion coefficient is again 365 days. Okay. It has been adopted from the previous question. Okay. So we have dt is equal to dref, that is 8 into 10 to the power minus 12 into tref is 28 days divided by 365 into 0.474. So when you solve the equation, what is the value of dt that you get? Yeah, so we get the value of 2.37, right? 2.37 into 10 to the power minus 12 meter square per second. Okay. So this particular value of the diffusion coefficient is uh, is given in option E. So option E is the right answer. So I think we can move on to the next question now. Question 5. Okay. So question 5 is again a numerical. So in this question, we need to find out what would be the ratio of the diffusion coefficients of silica fume concrete and Portland cement concrete, that is DSF and DPC, for 5% and 10% silica fume respectively. So silica fume is, you can call it as mineral admixture or supplementary supplementary siliceous material. Okay, sorry, supplementary cementitious material, which helps improve the various properties of concrete. Okay, so in the given question, we need to find out when we are replacing or when we are adding 5% silica fume and 10% silica fume, what will be the effect on the ratio of the diffusion coefficient between the silica fume concrete and the Portland cement concrete. Okay. So again, the equation uh, for this particular uh, problem is given in the lecture slide. So kindly take 1 or 2 minutes and let me know what would be the correct response. So let us look at the correct answer now, right? So the correct answer is option A, and the ratio of DSF and DPC for 5% and 10% silica fume are 0.43 and 0.19 respectively. Now let us look at how we are getting those respective answers, right? Yes, so we have this question, right? We have this particular equation, DSF is equal to DPC into e to the power minus 0.165 into SF. Okay, here DSF corresponds to the diffusion coefficient of the silica fume concrete, and DPC corresponds to the diffusion coefficient of the Portland cement concrete. Okay, now plug uh, let us use this equation and plug the values known to us, and let us see what are the answers we are getting. Okay, So what is asked of us is to find out the ratio of the DSFY by DPC. That is given by E into minus 0.165 into SF. Okay, so let us see what will the answer be for 5% silica fume concrete. Okay, e to the power minus 0.165 into 5, which gives us the value of 0.438. Okay, 0.438. Now, let us see how the ratio changes if we are using 10% silica fume instead of 5% silica fume. Okay, so we have DSF by DPC is equal to e to the power minus 0.165 into 10. Okay, so this gives us the value of 0.192. Okay, so the ratio DSF to DPC for 5% silica fume concrete is 0.438, and the ratio of DSF by DPC for 10% silica fume concrete is 0.19. So we can see that the same trend is observed in this particular graph also. In fact, we can see that these values exactly corresponds to the graph which is presented over here. So when we are using 5% silica fume, we can see that the ratio of DSF by DPC is 0.438, right? And when we are using 10% silica fume, the ratio of the diffusion coefficient is around 0.192. Okay, so essentially what we can make out, what the physical meaning of this particular results is that when we are increasing the percentage of silica fume in the cement, the diffusion coefficient uh, reduces drastically. Okay, it reduces exponentially, and when the diffusion coefficient reduces, the quality of concrete improves because even the migration is sort of restrained. Okay, so the correct answer for this particular question are 0.43 and 0.19 respectively. Okay, so we'll move on to the next question, right? So we have it is 7:55 around right now, and in the next 1 hour or so we need to cover another 15 questions. Okay, but the remaining 15 questions will be mostly theoretical or conceptual based. So let us proceed to the next question. Okay. So as per the next question, for the concrete shell structure shown in the figure, which kind of chemical admixture must be added to increase its durability? Okay. So there are 5 options uh, for this question. So take 1 or 2 minutes and let me know what is the correct response for this question. So as we have seen in this week's lecture, there are different types of admixtures that are added to concrete to improve, that are added to cement or concrete to improve its properties. So there can be mineral admixtures or chemical admixtures. Okay. So for this kind of a shell structure, uh, which of the chemical admixtures are most important in order to improve its structural performance as well as its durability? So that is the question. Okay. So we have retarders, we have the accelerators, we have the air entraining agents, then we have the shrinkage reducing agents, and then we have the low alkali, uh, use of low alkali cement. Well, the correct answer for this particular question is option D, or the shrinkage reducing agent. Okay. So as I already mentioned, there are different types of chemical admixtures which are added to cement or concrete to improve its properties and improve its structural performance and its durability. So retarders are used to reduce the, okay, we are going to uh, discuss in more detail in the upcoming slide. So essentially what we can see in this particular shell structure is that the ratio of the surface area to the volume of concrete is very high. Okay. So greater is the surface area, greater is the vulnerability of the concrete structure to lose its moisture and undergo shrinkage. Okay. So it is extremely important when we are constructing structures such as these. Uh, we have examples such as the Opera House in Australia, Sydney, and in India we have the example of Lotus Temple. And this particular structure is oceanographic in Valencia, Spain. It is very much important to use some sort of shrinkage reducing agents in concrete in order to prevent the shrinkage of concrete over time with the loss of moisture. Okay, so the most appropriate option for this particular question would be option D, that is the use of shrinkage reducing agent. So let us look at the various types of chemical admixtures and the corresponding implications on the durability of concrete. So retarders are used to increase the setting time and ensure that they are still workable. Then we have the accelerators, which can improve the setting time and increase the strength gain, which are very important in the cold climates, where in cold climates it can take little longer in order to um, ensure the setting of concrete. So in those circumstances, accelerators play an important role in decreasing the setting time and increasing the rate of strength gain in concrete. And then this particular dome or structure or a shell-like structure is similar to the one we saw in our example, which is having a high, surface area to the volume ratio. So it is important to preserve. Important to preserve the durability of the structure by using some sort of shrinkage reducing agent. Then superplasticizer, we know that it improves the flowability or the workability of fresh concrete. Then air entraining agent, it is important to resist the phenomenon of freeze and thaw, which causes fracture within concrete. And finally, in structures which are susceptible to corrosion, we can use some sort of a corrosion inhibitors, okay, to prevent the corrosion. So to reiterate myself, for the question 6, for a shell-like structure which is having a very high surface area to volume ratio, we need to use the shrinkage reducing agents to improve the durability of concrete. So we'll move on to the next question. So the next question, it is with respect to the phenomenon of alkali silica reaction or the alkali aggregate reaction. So out of these 5 options, we need to select the correct statements. Okay. Take a few minutes and let me know what is the correct response. So the participants can actually unmute themselves and participate in the discussion in giving the right answer. So the first statement is alkali silica reaction is the chemical reaction between silica of concrete, silica of cement and the reactive alkalis in aggregate. The second option is ASR gel will be formed only within the aggregate, which expands upon absorbing the water from the surrounding concrete. The third statement is as the tensile stresses within concrete increase due to expansion, it undergoes cracking. The fourth statement is ASR gel forms at the initial stage of concreting, and old concrete is completely free of the cracks due to this mechanism. And the fifth statement is the use of supplementary cementitious materials and lithium impregnation are some of the preventative measures against the ASR. So the correct answer for this particular question is options C and E. Okay. So let us look at each of these statements in detail. So we'll go statement by statement. So alkali silica reaction is the chemical reaction between the silica within aggregates and alkali in the cement. So it is we have interchanged the words here. Okay. And the ASR gel is formed surrounding the aggregate. Okay, not within the aggregate. So it is usually formed around the aggregate particle. So the second statement is also incorrect. But the third statement is correct. The tensile stresses within the concrete happens due to the expansion of the uh, ASR gel, okay, when it absorbs the moisture from the concrete. So the statement C is correct. Statement D is incorrect because the ASR gel, it is generally associated with the older concrete or the latest stages of concrete, okay, and it is not associated with the fresh concrete or the initial stages of concreting. And finally, the option C is correct because the use of supplementary cementitious materials and lithium impregnation can help in preventing the phenomenon of ASR. Okay, so to sum up, option C and E are the correct responses. So we'll move on to the next question. So what are some of the means of controlling the sulfate attack in concrete? Okay, so there are multiple correct options for this particular question. So take a few minutes and let me know what is the correct response. So the participants can actually unmute themselves and participate in the discussion. So it is meant to be an interactive session. Okay, feel free to raise your doubts and participate and learn along the way. Yeah, so the correct answer for this particular question is, so there are multiple options which are correct. So options D and F are the correct responses for this particular question. Okay. So again, I'll go statement by statement and let me know why options D and F are correct. So increasing the amount of gypsum is detrimental to the quality of the durability of concrete because uh, the use of gypsum, it leads to a very weak CSH paste. That is, the products of hydration are weak, which leads to the deterioration of concrete. Okay, so increasing the amount of gypsum is detrimental to the cement quality or the concrete quality, and lower amount of C2S. Again, if you increase the quantity of C3A, it leads to a early heat of hydration, okay, which leads to the degradation of concrete over time. Okay, again, the statement B is incorrect. Further, cure the concrete above 80 degrees Celsius. So we might have seen in some of the previous lectures that it is usually desirable to keep the curing temperatures below 65 degrees Celsius because increasing the curing temperature actually leads to phenomena such as the delayed ettringite formation, which is detrimental to the durability of concrete because it leads to cracking of concrete and so on. And the statements D, the use of supplementary cementitious materials, they are useful in controlling the surface attack, the sulfate attack in concrete. So option D is correct. Option E is not related to the sulfate attack because use of air entraining agents helps in improving the resistivity of concrete against the freeze and thaw effect. We'll be discussing that in a subsequent question. And option F is correct because use of sulfate resisting cement. Actually, we are using certain additives which improves the resistivity of concrete against the sulfate attack in concrete. Okay, so of the 6 options that I mentioned this in this particular question, option D and option F are the correct responses. Okay, so we look at the sulfate attack in some detail. Okay, so the sulfate attack can be 2 types. One is the external sulfate attack and the internal sulfate attack. So some of the external sources of sulfate attack are the soil, which is rich in sulfates, and we have the groundwater, which can have a higher concentration of sulfates such as the magnesium and other alkali sulfates. And there are other sources of external sulfate attack as well. And this is the essential mechanism behind the sulfate attack, right? So we have the calcium hydroxide, which is a byproduct of cement hydration, which can interact with the sulfate and which can lead to the formation of gypsum. So this gypsum actually weakens uh, the concrete. Okay, this can reduce the compressive strength of concrete, which is why the formation of gypsum is detrimental to the durability of concrete. And then we also have this monosulfate. So this monosulfate it usually forms when there is a high C3A content in cement and there is high heat of hydration. It leads to the formation of monosulfate, that is the sulfates are locked here, and then whenever water the moisture becomes available, it leads to the delayed ettringite formation. And as we have seen in the previous lecture, because of the crystalline structure of the ettringite, it can lead to the cracking of concrete and it can lead to the porosity and the ingress of various chemicals, which is why uh, the formation of monosulfate in the initial stages and the delayed ettringite formation and the cracking of concrete are harmful for the durability of concrete. Okay, so some of the control strategies to prevent the sulfate attack are we need to use a low water to cement ratio and use some kind of a supplementary cementitious materials such as fly ash, blast furnace slag, silica fume, and so on. And we need to try and use sulfate resisting cement wherever we feel that the concrete can be vulnerable to some kind of a sulfate attack. Okay, so we can move on to the next question. Okay, so the question 9 is the popping out of aggregate particles is associated with which of the following degradation mechanisms of concrete? Okay, kindly take a few minutes and let me know what is the correct response. So the popping out of aggregate particles is associated with which kind of a degradation mechanism? So the correct answer to this question is, so the correct answer, okay, the correct answer to this particular question is option D, that is, okay, yeah, The correct answer is option D, that is freezing and thawing of concrete. Let us look at the explanation for this particular uh, question. So here what we have is the this dark gray circle represents the aggregate, okay, and this light gray mass around the aggregate corresponds to the cement, the hardened cement paste. So what happens is that whenever there is a void between the cement paste and the aggregate, okay, so there can be accumulation of moisture. So whenever there is a freezing of the moisture, we know that there is anomalous expansion of water at sub-zero temperatures in cold climates. That leads to the expansion of the concrete mass, and this expansion leads to the cracking within concrete and freezing. So freezing within concrete is related to the formation of cracks, and then thawing is increasing the temperature. So when the winter is over, when uh, the subsequent summer season comes, so there is thawing, so that is there is melting of the moisture, so there is a sequence of formation of cracks, then accumulation of water, then further there can be freezing, formation of more cracks, expansion of the existing cracks, formation of new cracks. So that this is how the freezing and thawing leads to the cracking within concrete, right? And if there is accumulation of water within the aggregate particle, so there can be a popping out of the aggregate particle. So what I mean to say is that the popping out of aggregate particle is associated with the freeze and thaw degradation mechanism of concrete. Okay. So option D is the correct response. So we can move on to the next question now. So the question 10, it is based on the lecture slides. Okay. So as per the ACI 318, ACI 318 is the American code for structural concrete. So the ACI stands for American Concrete Institute, and 318 corresponds to the code for the practice of reinforced concrete design, and it is similar to our IS 456. Okay, so as per this code on the American Building Code and the requirements of structural concrete, what do type 2 and type 5 cement correspond? Okay. So what does type 2 and type 5 cement mean? Okay, kindly take 2 minutes and let me know what is the correct response. So this is based on the lecture slides. So you can have a look at the lecture slides if you want to uh, answer this question. So whenever the external environmental factors are not conducive to the durability of concrete, we need to use special types of cement by modifying its constituents. Okay. So the correct answer for this particular question is option A. Okay. Right. So whenever we are limiting the volume of or the percentage of C3A, so we have seen that there are four types of box compounds, or uh, they're the main components of cement, which helps in the hydration process and in the strength gain, that is C3A, C2S, C3S, and C4AF. Okay, and we have seen that C3A is responsible for the high high initial strength gain in cement. Okay, so whenever we feel that the concrete that we are using is vulnerable to the sulfate attack, we need to limit the proportion of C3A, okay, to limit the initial high heat of hydration so that it is not vulnerable to the sulfate attack. So we try to limit the C3A to less than 7%. So as we can see from the lecture slides, for type 2 cement, we try to limit the proportion of C3A to less than 7%, and we try to limit the C3A to less than 5% for type 5 cement as per the ACI code. Okay, so option A is the correct answer. So statement B is incorrect because we are not dealing with C3As. We are rather dealing with C3A. And as we discussed in the previous question, air entraining agents is corresponds to the freezing and thawing effect. Okay, it doesn't have to do with the sulfate attack, right? And yeah, again, this is not the correct response. The sulfate resisting compounds. And also the RCPT value, okay, the type 2 and type 5 doesn't have any direct correlation with the RCPT values, corresponds to the chloride penetration. Okay, option is the correct answer. So we can move on to the next question, right? So we have described various types of degradation mechanisms within concrete. So try to match them with the corresponding definitions given in the right hand side of this table. Okay, kindly take a few minutes and let me know what is the correct response. Okay, so the different types of degradation mechanisms mentioned are cavitation, abrasion, erosion, and corrosion. Okay, so I think we can go ahead with the correct response if nobody wants to answer, right? So we have cavitation, abrasion, and erosion are various forms of mechanical deterioration. Okay, thanks for the response. Option D. Let us look at the correct answer. Yes, option D is the right answer. So cavitation corresponds to the rapid development and dissipation of water bubbles, and it can be mostly observed in the hydraulic structures such as the spillway of the dams, right? And option B, abrasion corresponds to the impact of small particles on the concrete surface, right? Uh, so we'll be looking at the images next. So the aberration, we can see that the wheels of an aircraft on the runway, that can lead to the aberration. Okay, and cavitation, here we can see that on the uh, in the hydraulic structures in the spillway of the dams, we can see that the cavitation can occur due to the formation of air bubbles and their dissipation, and the formation of water jets, and the impact of these water jets can lead to the formation of cavitation. Then we have the erosion. Erosion is related to the uh, erosion is the impact of the particles of moving water scrubbing the surface. And ultimately, we have the corrosion, which is essentially an electrochemical process which leads to the formation of rust in the steel reinforcement. Okay, so here are some of the images for the erosion. We can see that erosion in this canal and corrosion of this structure standing in water. You can move on to the next question now. Okay, so we have the various images of deterioration within concrete. So try to match the images with the various degradation mechanisms mentioned in the question. Okay, take a few minutes and let me know what is the correct response. So the first we have cavitation, then we have corrosion, then we have the freeze and thaw, finally we have the alkali silica reaction. Okay, I hope that the text in the slide are clear. So this is image A, image B. So in image A, we have this or a map or pattern cracking. Then this is image C, and then we have D cracking in image D. Okay, so there is a response, I think, in the chat box. Okay. Okay, so we can have a look at the correct answer now. So the correct answer is option C, right? So yeah, so first we have cavitation. So cavitation corresponds to this image C in the spillway of this dam. And the second is corrosion. Corrosion, you can see that it corresponds to the figure B, where there is some kind of a orangish brown deposition on the surface of concrete because of the leaching of the ferrous oxide compound, because of the formation of rust. Then we have uh, the third mechanism, which corresponds to the freeze and thaw. It is associated with the formation of decracking. Okay, So that is why uh, mechanism 3 corresponds to image D. And finally, the alkali silica reaction, it leads to the formation of a map or a pattern type of a cracking. So option 4, mechanism 4 is related to image A. Okay, that is why option C is the correct answer. We can move on to the next question now. Okay, which of the following factors are conducive for the formation of corrosion in steel reinforcement? Okay, so there are multiple correct answers for this particular question. Take a few minutes and let me know what are the correct options for this question. So one hint that I can give you is that out of these 6 options, five five options are conducive for the formation of corrosion in steel reinforcement. Okay, there is a response. Okay, A, B, C, D. Okay, let us look at the correct response now. What are the correct options? So the correct options are B, C, D, E, and F. Okay. So let us go option by option and we can evaluate whether uh, these factors are conducive for corrosion or not. Okay. So low grade concrete, it is not directly associated with the corrosion of reinforcement. So you can have a low grade concrete like an M20 and it can still be having a good quality and not necessarily conducive for the corrosion. On the other hand, the ingress of chloride ions, okay, the chloride ions, it can penetrate the volume of concrete and it can lead to localized corrosion in the steel rebars. Okay, the chloride ions are uh, quite harmful uh, for the corrosion of concrete. Then we have the hot and humid climate. We know that when the concrete is when it is permeable, and whenever moisture and oxygen becomes available, so it becomes conducive for the formation of rust. And then the carbonation of concrete also leads to the corrosion in steel rebars. So because whenever there is a reaction between uh, the moisture within the concrete and the carbon dioxide in the external environment, it leads to the calcium carbonate, which leads to the reduced pH of the concrete volume. And this reduced pH, it can lead to the dissipation of uh, the protective the protective oxide layer outside the rebar. Okay, so again, carbonation is detrimental to the corrosion of steel rebar. And use of dissimilar materials, again, it can be conducive to the corrosion. And finally, if you are providing the permeable concrete cover, again, that can lead to the corrosion within steel reinforcement. So in this slide, we are trying to briefly explain what is the corrosion. So there is anodic reaction where there is electrons are being emitted over here, and here, you know, uh, in the cathodic reaction, again, it takes the electrons and it leads to the hydroxyl ions. Okay, and these ferrous ions and hydroxyl ions. Okay, there is a formation of an electrolytic cell over here, and it leads to the formation of ferrous oxide, ferrous hydroxide, which is nothing but rust. So accumulation of rust is nothing but the corrosion of reinforcing bars. Yeah, and I have already discussed earlier that the ingress of chloride ions and the carbonation of concrete, it leads to the destruction of the passive oxide film that is surrounding the rebar because of the reduced pH. Okay, that leads to the corrosion of reinforcement. Okay. Yeah. So again, we have seen that this is adopted from the lecture slides. So it discusses the various agents which are responsible for the corrosion of reinforcing bars, right? So with that, yeah, options B to F, all of them are responsible for the corrosion of steel reinforcement. With that, I think we can move on to the next question. Okay. So it's a quite lengthy question. Take a few minutes and let me know what is the correct response. I will read out the question. In the context of the deterioration of reinforced concrete hydraulic structures, such as spillways and sluiceways, which of the following correctly matches the primary cause of surface damage with its mechanism? So essentially, we need to match the mechanism with the correct description or the definition of the mechanism. Okay, we have abrasion, erosion, cavitation, erosion, and again another definition for cavitation. We need to match the mechanism with the appropriate definition. There is a response. Let's see. Okay, so the participant has mentioned that it's the first option, and yes, the first option is absolutely right. So as we can see, abrasion is essentially the erosion caused by the solid particles, and option A is incorrect. Option B is correct because it refers to the surface wear caused due to the suspended solid particles. And cavitation, this definition is incorrect because it is not associated with the water carrying the core sediment. Option D, that is also incorrect because erosion is not associated with the collapse of vapor bubbles. On the other hand, option E is correct because cavitation is associated with the formation and the collapse of the vapor bubbles, okay, which can cause pitting on the surface. So as the participant has correctly answered, option 1 is correct. That is, statements B and E are the correct responses. So we can move on to the next question. So you can look at the explanation later on. We have another 20 minutes and we need to cover another 6 questions. So let us move ahead. So again, question 15, it is a conceptual question. I will read out the statements. Let me know what is the correct answer. In reinforced concrete, the passive film protecting steel reinforcement can be destroyed by carbonation and chloride ingress. Which of the following statements are correct? So there are 5 statements. Kindly read them carefully and let me know what is the correct combination. I'll wait for other 20 seconds uh, for the answer. Then we can move ahead with the correct response. It seems like right. So participant is saying option one. Okay, so again, exactly, it's absolutely right. Option one is the correct answer because statement A, the carbonation induced corrosion occurs when the carbon dioxide penetrates concrete and lowers the pH. So we have seen that there is a protective oxide film surrounding the rebar whenever it is lowered. So this oxide film gets depassivated and it makes way for the corrosion of rebar. Option statement A is correct and option B is also correct because the chloride induced corrosion can occur even when the concrete is alkaline, but if the chloride concentration on the steel surface exceeds a certain threshold. Okay, option statement B is also correct. Okay, option C is incorrect because carbonation does not necessarily have to form these crystals around the rebar. So carbonation essentially reduces the overall pH of the concrete. So option C is wrong. Option D is correct because the ingress of chloride ions does not necessarily reduce the pH, but it still can break down the passive film surrounding the rebar. And finally, option C is incorrect because there is no evidence to show that in dry environment the carbonation can proceed faster. Okay, so the correct statements are option A, B, and B. Okay, you can look at the correct explanation. So in option E, so the carbonation can proceed the fastest in case of the moderate humidity. So we'll move on to the next question. We have another 5 questions in today's session. Which of the following options are incorrectly matched considering the prescriptive and performance design of durability of reinforced concrete? Okay, so you need to identify the options out of the 4 options which are incorrectly matched. Okay, there can be one correct answer or there can be multiple incorrect options. Okay, so we have seen in this week's lecture that there are two types of approaches towards the durability design, that is the prescriptive design and the performance based design. Okay, okay, so I think the participant has responded with option B. Okay, so let us look at the correct answer now. So the correct answer is option C, that is option C is incorrectly matched. Okay, let us look at the table from the lecture slides, right? So basically we have the prescriptive based design and the performance based design. So the prescriptive design is that which is given by the hotel provisions, right? So prescriptive based design has uh, the service life is not specified. On the other hand, in the performance based design, the service life is specified, and in the prescriptive design, durability is assumed, and in performance based design, it is designed for durability, and in prescriptive based design, it aims to avoid deterioration. On the other hand, in the performance-based design, we are not claiming that we are going to avoid deterioration, but we are taking necessary steps in order to provide a resistance to the deterioration. Okay, so let us look at the option once again. So it provides certain concrete composition and concrete cover. So option A is correctly matched, and option B is also correct because here life is not specified, but here life is specified, and here the options are interchanged. Okay, prescriptive design aims to avoid deterioration, but performance-based design aims to uh, design for resistance against deterioration, and option B is correctly matched. Durability is assumed, and durability is a design factor. So to sum up, option C is the correct answer. Uh, Kindly have a look at the questions once again along with the correct answer and the explanation. We'll move on to the next question. Okay, we'll discuss this in the subsequent questions. Yeah. So identify the incorrect statement with respect with reference to the tests on durability of concrete. Okay, so we have framed 6 statements based on 3 different tests to assess the durability of concrete. Identify the incorrect statement. Again, this question has been adapted from the lecture slides. Is the response okay? I think the participant has answered it as option A. Let us look at the correct answer. So, option B is the correct answer, or option B is the incorrect statement. Okay, we'll look at this, right? Uh, so we'll try to uh, address the discussion with a focus on the correct statement. Okay. Oxygen permeability test is conducted to evaluate the resistance of concrete to carbonation. Okay. And higher the value of OPI, higher is the susceptibility to the carbonation. Okay. Okay. So the option A is correct because oxygen permeability is done uh, to measure the resistance to carbonation, right? Option A is, sorry, the statement A is correct. And secondly, higher is the value. Yeah. So we want to ensure that the value of OPI is having a lower value. If the value of OPI is less, then the resistance to carbonation is also higher. Okay, so that is why the option B is incorrect, while the rest of the statements are correct. So I request you all to have a look at the statements later on. With that, I think we can move on to the next question. Okay, I will read out the statement. Concrete structures in coastal environment are classified under which category of environmental exposure condition as per IS 456? And what is the corresponding nominal cover to the reinforcement for M40 concrete. Okay, take a few minutes and let me know what is the correct answer. So do we have a response? Okay, so this particular question is code based, and as per the IS 456, in one of the tables, we see that corresponding to a coastal environment, it is identified as a one of the categories of environmental exposure conditions, right? We need to identify that. And for M40 concrete, what is the corresponding nominal cover to the reinforcement? Okay, so we have the response as option C from the participant. Let us look at the correct answer. Yes, option C is absolutely right. Okay, we'll look at the explanation now. So we have table 3 as per clause 8.2.2.1. So clause 8.221, right? Table 3. So we have for the concrete exposed to the coastal environment, it comes under the severe category. And correspondingly, as per the clause 26.42 and table 16, okay, corresponding to a severe exposure concrete, we need to provide a nominal concrete cover of 45 millimeter. But if you look at the notes under third point, whenever the concrete grade is above 35 M35, we can reduce the nominal cover by 5 millimeter. Okay. So for a severe exposure, we can provide a concrete cover of 45 minus 5, that is 40 mm. So for a coastal environment, option C, which corresponds to the severe uh, environmental exposure category and 40 millimeter, option C is the correct response. So we have another two questions and another 5 minutes. Uh, without any further delay, let's look at the next question. For the environmental conditions mentioned in the question 18, what should be the minimum cement content? What should be the maximum water to cement ratio and the minimum grade of concrete? Okay. Take a few minutes and let me know what is the correct response. So let me remind you that these are based on the Indian standard codes, and you can say that it is part of a prescriptive design because it is based on the codal specifications. Okay, I think we have answer option D as the answer. Okay, let us look at the correct answer. Okay, so it looks like option A was correct. Okay, let us look at why option A is correct. Okay, so in order to obtain these properties, we need to look at table 5 of IS 456. So if we look at table 5 of IS 456 as per clauses 6.12 and clause 8.241 and 9.1 for reinforced concrete corresponding to severe exposure condition, the minimum cement content has to be 320 and the maximum water to cement ratio has to be 0.35 and it has to be M30, right? Yeah. So yeah. So I request you to have a look at the question once again. Okay. So for severe exposure condition, the correct answers are 320.45 and M30. 320.45 and M30. Okay. We'll move on to the final question for today's live interaction session. Okay, so it is an applied question. Okay, I will read out the statement. Kindly think for a few minutes and let me know what is the correct response. It is intended to build a road bridge across the backwaters of Kerala exposed to the coastal environment. What would be the minimum grade of concrete, minimum cover, minimum cement content, and maximum water to cement ratio, assuming 20 size aggregates and factory made precast elements? Okay. So the precast elements are used for the bridge construction, and we need to assume we are using 20 size aggregates and a service life of 100 years. So it is for a road bridge. So you might have to, so the hint is we might have to look at the IRC specifications, Indian Road Congress, because the Indian Road Congress has specifications pertaining to the highway bridges. Okay, looks like we have a response. So the participant has said it is option A. Let us look at the answer. Okay, so it looks like it is option E. Let us look at why it is option E. So as I mentioned, we need to look at IRC 112 2020 Code of Practice for Concrete Road Bridges in India, published by the Indian Roads Congress. Okay, so we have, since it is a coastal environment, we have the severe exposure condition, and then the minimum cement content has to be 360 kg per meter cube, right? So 360 kg per meter cube. Maximum water to cement ratio is 0.45. Minimum grade is M30, and the minimum cover is 45 millimeter. However, if it is a factory made precast concrete element, we can reduce the minimum cover by 45 by 5 millimeter. So 45 minus 5, that is 40 mm. Now let us go back and look at the options, right? In option E, we have M30 concrete and nominal cover of 40 mm, cement content of 360 kg per meter cube, and maximum water to cement ratio of 0.45. Okay, and it is similar to what we can see in table 14.2 of the IRC 112 for severe exposure conditions. These we have these conditions which match with the option E of our question. Okay, so I think with that we come to the end of this question. So for the participants who have joined us uh, later, so you may have a look at the remaining questions. I will be uploading them on YouTube and the the Google Drive. Okay, so we'll meet again next week. Thank you for joining.
Excuse me, sir.
Yeah, yeah.
Sir, on Tuesday itself, we will be having the lecture every Tuesday.
Yes, yes. We'll be having on Tuesday, like we have two TAs in this course. So Harshit from IIT Bombay, he'll be taking the session at 6 o'clock and I'll be taking at 7 o'clock. So yeah, it'll go on consecutively for 12 weeks.
Every Tuesday.
Every Tuesday between 7 to 9 p.m. Mine will be from 7 to 9 p.m. and for him it will be from 6 to 8 p.m. You can join either of us.
Okay.
Yeah.
You
And
cannot
what
join both.
you can join both because his session ends at 6 o'clock and sorry 8 o'clock, and then you can join my session. But anyway, both our PPTs will be uploaded on the Google Drive, so you can access both of them.
Okay.
Yeah.
Because I have also registered for design of steel structure, which is
Okay.
also on the same day on Tuesday,
Okay.
uh,
Okay.
on the same time, 7 to 9. So I'm a bit confused which lecture is to be attended.
Okay. So it is completely up to you. Like you can anyway, the resources are available. Uh, Once the classes are over, the lecture is being uploaded on YouTube, and
You're going to upload these lectures also?
yeah, yeah. Have you not received the link for the YouTube channel and the this Google Drive?
I have not gone through. Let me just check it.
No,
You
no,
might receive.
no, no. You can stay online. I will just show you where it is being.
Okay.
Okay. Is my screen visible for you?
Yeah, 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 yes.
Okay. I think I have saved it. Yeah. So if you go to this Google Sheet, it might be accessible for all the students who have registered for this course. Yeah.
Okay.
Yeah, yeah. So this is from the other TA from IIT Bombay, and these are my this thing. So if you go to this link, you can go to my YouTube videos, week one, week two, and here you can access the slides. Okay, let me copy paste it in the chat box. Okay, you can just access. Yeah, I hope you can.
Yes, yes.
Yeah, yeah. So you please feel free to join us as per your convenience.
Okay.
Actually, the more the participants join, even we'll be encouraged to put in more effort in the live interaction session because eventually everyone will watch it when the exams are near. But
Yeah, yeah.
if you join us, then we can learn it together.
So, how the lecture goes? Suppose the third week lecture, if the fourth week lecture is shared, then you
Yeah.
are going to teach based on third week or fourth week. What is the?
So, so like today is week three, right?
Yeah.
So you might have seen that before starting the session, like I hope that my screen is visible.
Yes. Yes.
So this was the agenda for today's session. So uh, week three, uh, it was module three was based on the durability aspects of concrete, right?
Okay.
So next week I'm going to be taking up the actual members.
Module
So
four.
module four.
Okay.
So each week corresponds to different module.
And what he is teaching? The another guy?
He will also be teaching the same thing, but the problems are different.
Okay. The same modules. He is also going to teach the same modules.
Yeah, yeah, the
Problems
same.
based on same modules.
Yeah. So the basis for all these discussions is professor's lectures, which are already available for you on the NPTEL platform.
Yeah.
So we'll be taking up few questions in 2 hours, like how much ever questions we can discuss. Like for today's, I had 20 questions. So we'll be taking around 20 questions in these 2 hours so that you can understand the concepts and you can answer the assignment questions.
Okay.
Yeah.
So why don't you have different times, 5 to 7 and 7 to 9, so that we can attend both the lectures? Or
Yeah.
is afternoon?
So actually, we applied we didn't know that we were selecting the same slots. So we happened to apply in the same slot. So now I think it will be quite difficult for us both, to change. Uh, so yeah, so what you can do is you can join one of our lectures, and then whatever 1 hour uh, that this thing is there, the flash is there, you can make up later by watching our YouTube videos. So
Okay, but please try if it is possible. Then it would be great for us.
yeah, yeah. Actually, now it is difficult for us because the schedule is more or less fixed for the next 12 weeks.
Okay.
Yeah, I'll try to change.
Okay.
We'll put a request across to the NPTEL. So
Okay. One more question, sir.
yeah,
Uh, uh, the content what is shared on the as per weeks, the questions for assignments are based on
yeah,
that
yeah.
content,
Yes,
and
yes.
what your questions are also, they are different from assignments. They are extra questions.
Yeah, they are extra questions.
Okay, extra questions plus doubt solving and discussion with you. Okay.
Exactly, exactly. So whatever questions you're asking on the discussion forum,
Okay.
so I saw that you had asked one question today or yesterday. So you
Yes, today.
can, yeah, you can just before starting the session, we can accommodate the doubts if you're having any,
Okay.
and after solving those questions, we can move ahead with the sample questions. So
Okay.
these questions are designed to help you understand the concepts and solve the assignment problems and to solve the exam questions at the end of the the curriculum. So
Means watching lectures, solving assignments, and attending your lectures. This will help us to get good concepts clear and good marks in the final exam, I think.
exactly, exactly. So whatever professor's lectures are there, that is the basic,
Okay.
and whatever lecture notes are there, and whatever the live interaction sessions are there, those are add-ons. And you might be aware that the assignment questions that will count in the final grading of of your course.
Yeah, yeah.
Yeah, yeah. So yeah, please make sure that you are attending them as per your convenience.
Okay.
Yeah.
Thank you. Thank you so much.
Okay. Yeah. Thanks for joining. Look forward to having you again next week.
Yeah, thank you. Can I leave, sir?
Yeah, yeah, sure, sure.
Okay, thank you. Bye. Good night.
Thank you. Good night.